CPU which houses all the circuitry required to process input, store data, and output results. In the brain of a computer, the CPU is constantly executing computer programs that give it instruction on which data to process and in what order. We couldn't use a computer to run programs without a CPU. For instance, a straightforward calculator software might command the CPU to add the two digits and 2 and report the answer back. Thanks to a control unit that can understand program instruction and an arithmetic logic unit that can add numbers, simple calculator thanks to the control unit and working together. A CPU is integrated circuit, usually referred to as a chip. At the hardware level, millions or billions of tiny electrical components are integrated into an integrated circuit, which then organizes them into circuits and packs everything into the small space. Some of those layers are real components like transistors and chips, while others are abstractions like gates and logic circuits. It is astonishing that we can combine outstandingly straightforward components such as logic gates to produce CPUs that drive sophisticated gadgets including as our phones, laptops, and even self-driving automobiles. How computer hardware components work together. The components on the board can get power and communicate with one another thanks to the electrical circuits on the board. The CPU and the primary memory are typically located on the motherboard of desktop computers, and you can connect peripherals like graphics and sounds cards, memory, and other cards or cables to them. Importance of hardware. Hardware cannot run correctly without software. If the right hardware isn't used, your software might not run at all, or even at all. Both of these aspects must be considered when selecting your IT systems because they couldn't affect how you work, how productive you are, and how much money your business produces. Different types of storage media. Types of storage media. Hard drive components. A 5-tray RAID hard drive. Flash memory module. 3D X-point based. Optane SSD from Intel. Optical storage media. Hard drive. The physical device that houses all of your digital stuff in hard disk. Digital stuff that is kept on a hard drive includes your papers, photos, music, videos, applications, application prefers, and operating system. There are internal and external hard drives. The sizes of Each file that is kept on a hard drive is how it is identified. Text documents are often very small, whereas images, music, and videos all have bigger file size. Digital files are measured in megabytes, gigabytes, terabytes, and giga on a hard drive. A 5-tray RAID hard drive. This strapping with parity is used in the redundant array of separate drivers configuration known as RAID 5. No single drive is a bottleneck since data and parity are spread equally across all of the disks. Users can also reconstruct data with stripping in the event of a disk loss. One of the most used RAID configuration today, RAID 5, equally distributes read and writes. Compared to RAID 1 and RAID 10 configurations, it has greater usable capacity and performance as well as RAID 0. Hard disk drive minimums and maximums for RAID 5 groups are both 3. One of the most secure RAID configuration is RAID 5, which distributes the parity data across all disks. Flash memory, a non-volatile storage chip with a long lifespan that is frequently found in embedded systems. Even when they power off, it may retain the data and information that is stored. It is reprogrammable and can be electrically erased. EEPROM LED to the creations of flash memory, electrically erasable program read-only memory. 3D X-point based Optane SSD from Intel. Based on 3D X-point technology, the Intel Optane product range has access times and transfer speed that are far quickly than those of standard NAND-based flash memory, as opposed to NAND, which requires a series of read, modify, write operations in order to accomplish and write operations. 3D X-point addresses for read and write operations, specific cells rather than full blocks. The memory cells in 3D X-point technology are addressed individually, and there are two physical connections available. One is at the top of the 3D mesh and the other is at the bottom. This approach produces an ultra-fast technology with advantages like very low latency, simulators read and write operations at very high speed. Optical storage media. Low power laser beam are used as a electronic storage media to store and retrieve digital data in optical storage technology. A laser beam creates tiny pits that are placed in spiral pattern on the surface of an optical or laser disc to encode digital data. These holes are read by a low-power laser scanner which transforms reflection in amount of reflected light into electronic signals. This technology is used in WORM, write once, read many, a type of disk that can be written on once and read any number of times in WORM, write once, read many. A type of disk that can be written on once and read any number of times, and it never disks. The compact disc uses this technology to record sounds. It can be completely received because laser beams can be focused and controlled considerably more accurately than tiny magnetic hits, which allows for the condensing of data into a much smaller space. Optical storage offers higher memory capacity than magnetic storage. For instance, a whole much smaller space. Optical storage offers high memory capacity than magnetic storage. For instance, a whole set of encyclopedias can fit on a typical 12 cm 4.72-inch optical disc. Optical storage technology not only offers greater capacity but also more accurate duplication of sounds and images. Moreover, optical discs are cheap to produce because they are merely molds that are pressed from a master, much like phonograph records are. The discs themselves are relatively resistant to physical damage, and unlike magnetic discs and tapes, the data on them cannot be lost due to the power outages or magnetic disturbance. To keep them safe for contamination, they do not need to be kept in securely sealed containers. Because optical scanning requires has so few moving parts, it is also quite durable. The data recorded into the surface of early optical discs could be read but not erased or written since they were not erasable. When WRM and writable discs were developed in 1990s, this issue was resolved. The biggest remaining disadvantages of optical technology is that information can be retrieved more slowly than with conventional magnetic store media. Despite its slowness, optical storage is preferred for money-intensive applications, especially those that including still or animated pictures, sounds, and a lot of text.